Hello, my name is Jen Grantham, and this presentation will cover AppArmor and HTTPS. The agenda for this presentation, as mentioned, will cover AppArmor and HTTPS. We'll also cover Apache and Internet Information Services, IIS. Within these protocols, we'll also discuss the general information along with the hardening recommendations. First, let's talk about AppArmor. AppArmor is a Linux-based security module containing name-based mandatory access controls, also known as MAC. The module is installed by default and utilizes profiles of applications to determine required files and permissions required by the applications. While some packages will have default profiles, generally profiles can be viewed in AppArmor-Profiles package. AppArmor has two modes of execution: complaining learning, where profile violations are permitted and logged. This is useful for testing and developing new profiles. We also have enforce/confined, which enforces profile policy as well as logging the violation. To discuss how AppArmor works, there's an optional AppArmor-utilities file, also known as UTILS, package that can be utilized for viewing existing profiles. This utility is a command line tool allowing users to change the execution mode, see the status of a profile, and create new profiles. The command to see the status of existing AppArmor profiles, sudo AppArmor_status. The directory where AppArmor profiles can be viewed is /etc/AppArmor.d. Additional important commands can be found within the Ubuntu server doc. I've provided the website link within this presentation. Now, how do we create an AppArmor profile? When creating a new profile, it is strongly recommended to first identify a test plan and also establish test cases. These test cases can include, however not limited to, starting the program, stopping the program, reloading the program, testing all commands supported by the script. Once satisfied with the testing, the new profile is created by using the sudo aa-genprof executable. To include the profile in the AppArmor profiles package, a bug will need to be filed within the launchpad and include the test summary and the profile attached to the bug. Example profiles exist within AppArmor. These are known as pre-existing profiles. While these profiles aren't necessarily working profiles, they can be considered a template helping give users a head start on creating new profiles. These profiles exist in complaint mode, allowing for user testing. While AppArmor profiles enforce policies to make sure programs behave in the way that they should, there should be some additional hardening recommendations within AppArmor to further protect the server. The first recommendation is to create profiles for programs that are expressed or exposed to attacks, reducing the workload to further harden the server. The second recommendation is to restrict the website's access through mandatory access controls. In the event of a website being compromised, the damage will be confined to the website and not the server. By default, AppArmor sets up application profiles to protect standard Linux services. In order to ensure the critical applications are protected, you should utilize AppArmor tools to create profiles for these critical applications. It is worth noting the default app installation from Linux is discretionary access control. This is less secure than the mandatory access control. Lastly, the third recommendation is to utilize ChangeHat for profiling web applications. ChangeHat enables programs to change to a hat within an AppArmor profile, allowing the user to define security at a more granular process. The hat is where a program uses different security contexts distinctive from the access of the main program. For our Linux server, we will be using Apache application. Apache is a free and open source web server delivering web content through the internet. Apache is considered the most popular of the HTTP clients And while Linux is the operating system handling the operations, Apache is the web server processing the request and serving WebSS content via HTTP. Apache also assists with balancing the traffic across the web servers, handling the HTTP and HTTPS request. Hardening requests for Apache include restrict outgoing connections. This is done by limiting the possible outgoing connections to only what is needed. Restricting resource usage. This is done by limiting the number of Apache processes suitable for your server. And lastly, we should mitigate the risk for memory leaks. This can be done by lowering the setting under the max request per child. The initial recommendation is to have the setting reflect no more than 10,000. However, in cases of severe memory leaks, the setting can be as low as 500. HTTPS. What does this stand for? HTTPS stands for Hypertext Transfer Protocol Secure and uses the Transport Layer Security, also known as TLS, encryption protocol to encrypt communication. TLS secures the communication utilizing an asymmetric public key infrastructure. This security system allows for using two different keys to encrypt communication between the parties, one being a private key, the other being a public key. The private key is controlled by the owner of the website and kept as private. The key lives on the web server and is used to decrypt information encrypted by the public key. The public key is available to everyone who wants to interact with the server in a secure manner. Information is encrypted by a public key and then decrypted with a private key. Now, what is the difference between HTTPS and HTTP? Well, it's quite simple, actually. The only difference being is the encryption and verification of the data. Data sent over HTTP is sent in plain text without any encryption or security mechanisms. This allows for information to be intercepted by anyone with access to the network. HTTP sends data over port 80, while HTTPS sends data over port 443. HTTP operates in application layer, whereas HTTPS is in transport layer. There isn't an SSL certificate required for HTTP, whereas in HTTPS it does require an SSL certificate and is signed by a certificate authority, also known as CA. Now, what is Internet Information Services? Internet Information Services, also known as IIS, is a web server on Microsoft running on Windows operating system. It is utilized to exchange static and dynamic web content with Internet users. IIS, where is this utilized? It is utilized in web hosting, hosts enterprise web applications and websites. Approximately 30% of the websites run over IIS. Logging. IIS server logs contain critical information about the server and website. It includes usage patterns and any performance issues. This helps with troubleshooting and quickly identifying issues. We also have request filtering. There's a module within IIS that's used for scanning and filtering potentially dangerous client requests. The user can configure traffic filtering rules based on parameters such as file extensions, URL length, and maximum string size. And lastly, we have the native support. IIS supports Microsoft.NET Framework and libraries, allowing developers to quickly build and deploy managed ASP.NET. Now, with everything else as we've done, we'll also come up with propose some hardening recommendations. The very first one would be to secure the cookies. You have applications that do not require access to cookies. These can be secured by sending them what's called HTTP only. Also, we should prevent non-HTTPS connections. Require every website to use SSL. All requests going to HTTP port 80 need to be directed to the SSL version of the site. And we also have the usage of a referrer policy. When a web browser follows a link from one site to another, it sends a referrer header, and the next website can be read. Attackers utilize this to hijack your website. If the user's URL to their page contains sensitive information, it shouldn't be sent to an external site. The referrer policy will assist in prevention of this. Lastly, here are my references that I utilized in my research. Many thanks for your time, and best wishes to everyone.